section will be something called Detour Proof. To prove, say, one triangle is congruent to another, first we have to prove, believe it or not, that another two triangles are congruent. For example, if you have this kite, okay, let's draw it a little bit better. If you have a picture like this, and it's labeled A, B, C, D, and point E in the middle, and you're given the following. You are given that AB and AD are equal. AB and AD are equal in lengths. And you're also given something, okay, and you want to prove or conclude that triangle ABE, the upper left triangle, and triangle ADE, triangle 1 and triangle 2 are congruent. But you're given one other piece of information that seems to have nothing to do with the triangles in question. Have nothing to do with it. And when you look at this, you may say, well, when it comes to triangle 1 and 2, all I know is that one pair of sides are the same length. But, you know, I need SAS or SSS, things like that. Now, they do tell us that BC and DC are equal in lengths. They do tell us that. So what we need to do is come up with other triangles. Now, is there a triangle, for example, that has 1 slash and 2 slashes? The answer is yes. AC split it in half. You have ABC, that's one triangle, and you also have ACD being another such triangle. You have the left one, you have the right one. Now, when you look at the left triangle, they have 1 slash and 2 slashes. One side with 1 slash, one side with 2 slashes. When you look at the right triangle, the right half triangle, they also have one side with 1 slash and 2 slashes. But you know what? They even have a third side equal, AC. So now you have these two triangles congruent. You now have these two triangles are congruent. And you can talk about corresponding sides, for example. Okay. So now what you can say is this angle up here and this angle over there are equal to one another. So now let's talk about just the top two triangles, the ones marked 1 and 2. So you have those two angles are equal. And also in triangle 1 and triangle 2, you have a side with 1 slash. But then you can say AE equals AE. So you'll have side, angle, and side for both triangles. And then they're corresponding, and then we're done. They are actually congruent. by side, angle, side. So statement and reason. You are given that AB is congruent to AD and that BC corresponds to DC in length. This is the given. So I'm going to redraw this picture and then we'll label it as we go along. Well, let me use the same labeling as before. Okay, so we have that AB and AD are equal in length, and BC and DC are equal in length. Now we're going to say that AC and A is congruent to AC. And this, of course, is the reflexive property. So now we have that the left triangle, and let's use another color maybe, and the right-hand triangle are in fact congruent. They are in fact congruent. Okay, so let's write that up. Triangle ABC is congruent to triangle ADC. And the reason is SSS. Now I'm going to say that this angle here and this angle here by angle A are equal. I'm now going to say that angle BAC is congruent to angle DAC. DAC. The reason is corresponding parts of congruent triangles are in fact congruent. Now, why is that? Well, in the left triangle, the red triangle, this angle is made up of one slash and the one that has no slashes, AC. And this right angle, DAC, is made up of one slash, there it is, and AC, which has no slashes, or just AC. So they are corresponding parts. Now I can say that AE is congruent to AE. And the reason is reflexive property. Reflexive property. So now, let us just draw this top half a little bit bigger. We have B, D, A, and it's cut by AE. And we know that BA and AD are equal. That was outright given. AE is equal to itself. And we just learned that this little angle by A and this other little angle by A, they are equal to one another. So if I may continue here, we say that triangle BAE, well, they say ABE. They want us to call it ABE. Sorry. Triangle ABE is congruent to triangle ADE. And the reason is side, angle, side. Congruent to side, angle, side. Side, angle, side. congruent to SAS. And that's that proof. Okay, so basically to prove one triangle was congruent to another, we used what is called the detour method. We introduced yet another triangle, and that helped us out. Have to be pretty clever. So basically, if using the two triangles that you want to prove congruent, if you don't have enough information, well then look yet for a second pair of triangles. Maybe that will help you. The next thing we're going to talk about is the midpoint. Here are the x and the y-axis. And you have some line. And this line starts at x1, y1, line segment, and it finishes at x2, y2. Well, there's a reason that point is called x1, y1. That's because if you happen to look straight up, you would see x1. If you happen to look straight across, you would see y1. Same argument here. That's x2, and on the y-axis right here is y1. Sorry, y2. Y sub 2. And although these dashed lines helped us, we don't really need it. Now, I want to find the middle. Well, with respect to x, it goes that distance from x1 to x2. Well, the point in the middle would be x1 plus x2 over 2. The same thing for y's. Y goes this amount. And the midpoint, well, it would be the average of those two. Well, it turns out that right here, that's the midpoint. That's the midpoint. And it is the average of the two x's, x1 plus x2 over 2, comma, and then the average of the two y's, y1 plus y2 over 2. That's how you find the midpoint. Now, if you were told that one line has one endpoint of a line segment is 3, 5, and the other one is 8, 11, you can find the midpoint pretty easily. Add up the x's divided by 2, comma, add up the y's and divide by 2. Well, I thought 8 was an odd number. How odd of me. Just to make the numbers nice, so let's let it be 9, 11. So 3 plus 9 is 12 over 2 is 6. 5 plus 11 is 16, divided by 2 is 8. The midpoint is 6, 8. You average the two x values of the endpoints. Average your two x values at the endpoints. Average the two y values at the endpoints, and you have the midpoint, 6, 8. The first number, 6, is the average of the x's. The second number, 8, is the average of the y's. And that's the midpoint rule. That's how you find the midpoint given 2 points. suppose you have a diagram as such. You have this nice triangle on top and this somewhat smaller triangle underneath. A, B, C, and D. And let's draw this line as well. Call it E. And we are given certain things and we want to prove some other things. Suppose you are given A is equidistant from B and D. And further, suppose AC bisects BAD. Ray AC bisects angle BAD. Angle BAD. Suppose that. And we want to prove that AC bisects BD. Now, if A is equidistant from B and D, that is the distance from A and D, and the distance from A and D are the same. That means AB equals AD. And you were told that AC bisects angle BAD. It bisects this angle by A. It cut it into two equal pieces. Okay, we have that. Now you want to prove that AC bisects BD. AC bisects BD. Well, there's BD, and you want to show that those two are equal. That is, BE and ED are equal. So that is, you want to show that BE is congruent to DE. You want to show that those two lengths are equal. And it's very immediate because you have this upper triangle here and you have this upper right hand triangle there. And so let me put in red stuff that we're adding that we weren't given. We know that AE equals AE. So triangle 1 and triangle 2 are congruent because they both have one side equal, they both have a second side equal, and the angle in the middle of those two sides are equal. So by SAS, they're equal. And then we can argue that BE and DE are the same lengths. And therefore, because they're corresponding parts of congruent triangles. And therefore what? Therefore, AC, this long line, AC, it really did bisect BD, because it did cut it into two equal parts. So basically, we didn't even need those two lower triangles, the BCE, the two that have the check in them, coincidentally. BED, BEC, we didn't need this triangle here, and we didn't even need this triangle there. In other words, you didn't need it at all. It was extra. They could have just said AC, does AC bisect BD? Or prove that AC bisects BD. Okay, so that wasn't necessary to be given, but we were, so I will put it back. Okay, statement reasons. Statement 1 is, now remember that this just says that AB and AD are the same length. That's what that says. So you have all of this. That goes there, and the reason, of course, is it's given. And I think I need a little bit more space for the statements. So 1 is, it is given. Now number 2, I want to say that, in fact, AE is congruent to AE. And the reason is the reflexive property. And now I want to say that I've already said that AC bisects angle BAD. So now I want to say that angle BAC is congruent to angle BAC, or instead of C, I could have said E. And the reason is that's what a bisector does. An angle bisector bisects an angle into two equal angles, namely BAC and DAC. So now I can say, so now the picture is complete. Everything in the picture is valid, even the stuff in red. I can now say that triangle BAE is in fact congruent to triangle DAE. And the reason is SAS. SAS is congruent to SAS. Now, for number 5, I can say that BE is in fact the same length as DE. Why? Because they are both opposite the angle that has a black and a red slash. They're both opposite equal angles. Corresponding parts of congruent triangles are in fact congruent. Now number 6. I can say that AC bisects BD. The reason is that any line that splits a line into two equal parts is an angle bisector. Is a bisector. AC split, divided, split, BD, line segment AB, split line segment BD into two equal parts, namely BE and BE. Okay, so I got it. I got my conclusion. That finishes that problem. And erase the board, then we try another one. Okay, so we have this diagram with the triangle. And we are told that point B is at 2, 1. Point C is at 12, 3. And point A is at 4, 8. The problem says, find the coordinate of the points where, okay, so find the point where the median from A intersects BC. The first thing we should talk about is, what is a median? Well, the median basically goes to the midpoint. It goes to the midpoint of the other side. Goes to the midpoint. So that's the median AD. So the question is, what is point D? For point D is easy. I know the two endpoints that connect, that goes through D, B and C. It's the average of the two x's, 2 and 12. You add them up, divide by 2, comma, you add up their two y's and divide by 2. Now be careful about saying 2 goes into 2. It does. A lot of you actually say, and this is very, very bad, because not only can't you do that, but then you're saying the answer is 12. At least say that 2 over 2 is 1 and call the answer 13. You also have to do 2 into the 6, into the 12 and get 6. And 1 plus 6 is 7. That, in my opinion, is way, way too hard to do. That is way, way too hard. 2 plus 12 is 14 over 2. 1 plus 3 is 4 over 2. So again, 2 plus 12 is 14. Divided by 2 is 7. And 4 divided by 2 is 2. So the answer is 7, 2. When they say the median from point A to any line, call out line segment BC. I meant to say line segment. Well, the median goes to the middle. That's the median. The line I just drew right here, assuming that where I put the X is the middle, that's the median. Okay, so when they tell you that in a triangle, the medians all intersect, well, when you go from here to the middle, and when you go from here to the middle of this line, and when you go from here to the middle of the next line, the medians all intersect. Okay, the medians all intersect. The medians go from a point to a line. What point on the line? The midpoint. Goes to the midpoint. It's a very straightforward problem as long as you're familiar with what a median happens to be. The median is just what I said. It goes from a point to a line. But there's many points on the line to go to. If I said, here's a point and here's a line, draw a line segment. Draw a line from that point to the line. Well, you can draw that line. That's correct. It went from this point A to the line segment. Or you can draw that line, or this line, or that line, or this line. Many lines. Which line should you draw if they call this line the median? Well, find the middle of that line. For argument's sake, we'll say it's there. So somebody asks you to draw the median from point A to the line segment AD. This is it. That's the one. And you know that this length and that length, they're equal. That's what median means. It's important. That's why I said it so many times. Okay, let's try another problem. Okay, here's a very good problem to be able to do. If you are given the diameter of a circle, so the center's on that line, and they give you 1 point, 3, 7. They give you another point, 9, 13. And they say, find the center. Find the center. The center. Well, it's the midpoint of this line segment. I know that because that length and that length are the same. It's the radius of the circle. Well, so what you do to find the midpoint is you add up the two x's, divide by 2. At least to note that first. Add up the y's and divide by 2. 3 plus 9 were the x's. When I add them up, I get 12. Divided by 2. That, of course, is 6. And when I add up the y's, I get 20. When I divide that by 2, I get 10. So now I know where the center is. The center is at 610. So given two endpoints of a diameter, you should be able to find the center. Now, of course, if this is the center and you're given this line segment, you're given these two endpoints, you can find that, but that's not the center. Okay, that's not the center. So finding this point is not enough. But if you have this line segment, which crosses the center and hence has a better name, it's called the diameter, if you found the midpoint, you found the center. Okay, let's try this one. You're given a triangle or a diagram. You're given this nice, beautiful triangle. There's another triangle inside it. A, B, C, D, and E. D, and E. And of course, this comes with some given. You are given that AB is congruent to AC. AB, AC, equal. You are given that AD and BC perpendicular. That means right angles. and you are asked to prove that BEC triangle BEC, the one in the bottom, is isosceles. You want to prove that this triangle right here is isosceles. Okay. So now we'll try the detour method. What we can say, and let me redraw this. Since we know that those two are equal, and we know that this is a right angle, and so with that a right angle, and we know that this, so we have a right triangle, so we can do hypotenuse leg. Well, we know that this side is equal to itself, and that these two sides are hypotenuses. You have this left-right triangle, and you have this right side right triangle. And the vertical line in the middle, this line here, that's in both triangles, and the hypotenuses are equal. So now we have that these two triangles are, in fact, congruent to one another. Well, that tells me in the left triangle, this side and that side are equal. They're corresponding. All right, so now I have the three sides equal. Okay, and now I know that this is equal to itself. I know that equals itself. So this lower triangle, call it 1 and 2, note that they're both right triangles. Those two triangles are congruent by the fact that the two legs are congruent. If you have two triangles, two right triangles, and they have two pair of congruent sides, two pair of congruent legs, then they are in fact the same triangle. And S, A, S. But now the thing is, how do you show that where I have the X and the Z, they are equal to one another? That I don't see so clearly. A, D, B, E, C. Oh, we just want to show the whole bottom one is equal. B, E, C. B, E, C. So I don't want to show anything about where I put 1 and 2. All right, let's try to write it off. Let's get our hands dirty. Let's see what follows. So statement, reasons. Statement 1 is this mess. Reason, good old given. All right. Now, what I want to say is that angle BDE and angle CDE are right angles. And the reason is perpendicular lines meet or meet at right angles. And I've already said in statement 1 that those two lines, AD and BC, are perpendicular. So, okay, these are now right angles. We said them. We said that. And AB and that are equal. I can try to show that the angles are equal. All right. So now what we have is the following. We have that the big left triangle, now I need to say that AD is congruent to AD, which is the reflexive property. So now I have that this is equal to itself. So in the left triangle, the big left triangle, DBA, and the right triangle, DCA, I claim that they're congruent by the HL theorem. Okay, but before you can use the HL theorem, you have to get that the triangles are right triangles. Number 4, triangle DBA and triangle DCA are right triangles. And number 4 is, remember what 2 said, any triangle with a right angle is a right triangle. Okay, now I can say statement 5, because the 2 triangles, the one to the left of this line and the one to the right of the line, they are both right angles, and they have a hypotenuse and a leg equal to one another. All right. All right. Okay, straightforward. So now I can say in statement 6 that BD is congruent to DC. Now we're talking about the big triangle. So for the next moment, we're not dealing with this at all. In fact, up until now, we haven't even mentioned that. Now, the left triangle 1 and the right triangle 2 are congruent. Well, opposite, 1 slash and x. You know, that has a circle. That's the third side. The right triangle has 1 slash and an x. Well, the other one must be circle. Okay, those are the corresponding ones. They really do correspond. Corresponding parts of congruent triangles are congruent. But in fact, we do have this. All right. Now, if I can show that 2 sides are equal to one another, or 2 angles are equal to one another, okay. Now, we know that these 2 angles are equal because the opposite equal sides. We know those big angles are equal. We know that those big angles are equal. Okay, I don't think we even need that. But now DE is the same as DE. This is by reflexive property. Okay, so now I need to also comment that this small triangle, call it 4 and 5, don't ask why I passed 3. I want to say that those are right triangles. And the reason is because the statement 2. These angles are right angles here. Okay, so triangle BDE and triangle CDE are right triangles. And number 8 reason is it's the same as number 4. Any triangle with a right angle is a right triangle. Okay, so now prove that this is isosceles. So now we're getting there. Since triangle 4 and 5 are right triangles, and we know that they are congruent at this point, and I'll state why in a moment. The reason is SAS. They both have a circle side and an X side, and the angle in between the circle and the X are the same. They're right angles. Okay. Therefore, angle, the two base angles, this angle here and this angle here, are equal. DBE, angle DBE and angle DCE are equal. And the reason is corresponding parts of congruent triangles are congruent. But if two triangles have two equal angles, okay, so I take this back now. Now, this is unbelievable. But now we're going to think of this as one triangle. And we know that the base angles are equal. Triangle BEC is isosceles. And the reason is any triangle with two or more equal angles is isosceles. Okay, so that problem was very long. It talked about the two big left and right triangles. It talked about this lower triangle being two triangles, number 4 and 5. And then it talked about it being one big triangle. Okay, so here we did a lot of detouring. We did a lot of detours in this problem. Let's try one more. Alright, let's try this problem. give a square, and we want to find the area of the square, and we want to find the center of the square, the dead center of the square. Here is the square, nice and square. Oh, I don't know why the rest didn't come out. The y-axis, the x-axis, and the square itself. And all I'll give you is, say, this point, -4, 0, and the fact that it is a square. So I want the area of the square. I want to know what it equals, and I want to know where the center of the square is. The center of the square is where? Well, the area. The area, I want this to be very routine. This length is 4. And if it's a square, so is that. So the area is 4 units by 4 units, or 16 units square. Now, what is the center? Well, if from here to here is 4, well then when I go down it's also 4. If you're at 0, 0, and you go down 4, you are at -4, 0. Now, I want to know what that center is. Well, if you think about it, the x value of the center is going to be in between those 2 points. And the y value of the center is going to be between those 2 points. Well, the center is just going to be the average of the x value of the center will be the average of the x values, 0 and -4. And the y value will be the average, oops, that's wrong, sorry, that should have been 0, -4, big mistake. It will be the average of those 2 numbers. And of course 0 plus -4 is -4 over 2, -4 over 2, it's -2, -2. That is the center. -2, -2. Okay, it's reasonable to assume that the x value would be in between there. That is, if you have a square, the center, the x value is going to be the average of the x values here. It's going to be dead center. And the y value will be the average of these 2 values, which is right there. And that's why that's the center. Okay, this completes this section. I hope it's helpful.